Okay, hello. We're going to go through the next step of activity calculations now. The previous short video showed you how to calculate ionic strength, mu, and I've got 0.021 molar solution of zinc chloride, and I've already worked this out. And in fact, I mentioned in the other video, there's the numbers are always the same. For a 1:2 or 2:1 salt, like zinc chloride, the ionic strength is 3 times the molarity. And so you can plow through the calculations each time, or you can memorize about 4 or 5 different things and save some time. In any case, let me show you, let's see, here we are. Now, once you have your ionic strength, mu, you're going to want to, first of all, look at the table. There's a table in your textbook, and I've provided one on the Moodle site that's downloadable and printable and all that kind of stuff. So the way this works is you've got your ion, and it's plus or minus 1. It doesn't matter what the charge is. They affect the activity the same. There's an estimate, an empirical estimate of the ion size in picometers, that's alpha. And then there's the ionic strength, mu, as we've talked about, and ranging up to about 0.1 molar. Beyond that, all of these calculations, the assumptions don't hold very well. And we just look up here at our activity coefficient, which we call gamma. In any case, let me see if I can, it's going to be too much trouble to scroll that down, but you got plus or minus 1, plus or minus 2, and so on. Now, as it turns out, 0.063, you go back to my whiteboard here, 0.063 molar is not on the table. We're going to have to, there's 2 ways to find that. You can do a linear interpolation, which I'll do in a different video, or the way I prefer is what's called the extended Debye-Huckel equation. It's an empirically derived equation. The 0.51 and the 305 are empirical constants worked out all way back in the 1930s or so. And so this makes a really good estimate. And this, especially if you plug it into Excel, you can save a lot of time. But we'll do that now. So we've got our mu, and I have looked up the ion radius, which is 600 picometers for the zinc ion. So let's plug everything in. Log gamma is negative 0.51 times 2 squared times the square root of 0.063 molar divided by 1 plus alpha being 600 times the square root of 0.063 molar divided by 305, and plug and chug on your calculator. And so log gamma is equal to negative 0.3428. And it's really easy to forget that that's the log of gamma. So gamma is going to be equal to 10 to the log, log gamma is 10 to the negative 0.3428. and that equals 0.637. 0.637. So that's, I think, the easiest way to do it. It's a little bit tedious in the calculation, but it's less trouble than interpolation. Interpolation is not that hard, but it gets a little bit tedious to set it up properly. In any case, that'll be enough for this one. And in another video, I'll show you how to do the linear interpolation.